In this video, we're going to talk about simplifying radicals and specifically rationalizing the denominator. So, when we have a radical like the square root of 20 here, all right? Square root of 20 is an amount. We don't know what it is exactly. Square root of 25, we know that's 5. But this is actually the same as 2 times the square root of 5. And that's kind of nice because this is a little smaller looking than this. So we don't know the square root of 20, but we can do this. And the reason why we can do that is because of our radical product rule. So this radical product rule says if we've got two numbers that are under a square root and we can multiply them and put them under one square root or vice versa. All right, so what we've seen with this square root of 20 deal here is that we can write this as the square root of 4 times square root of 5, because the square root of 4 we know, the square root of 5 we don't, but we get this formed, which is simplified. Okay, so that was simplifying when we're multiplying, or actually we kind of made it into multiplying and then we simplified. But what if we have a fraction? We're dividing. What do we do with this guy? Because we have something that's not in a square root on top, something that is in a square root. That's what we're going to find out here in this little lesson. So let's take a look at how we can kind of clean this up. Well, what we want to do when we're simplifying expressions that have square roots in the denominator is we want to get rid of that square root in the bottom. So what we have to do is kind of square it, but we want to multiply this denominator by the square root of 2. And we're allowed to do that with fractions if we multiply the top by the square root of 2. Because when we're multiplying the top and bottom by the square root of 2, we're really just multiplying by 1, right? Square root of 2 times, or over the square root of 2 is 1. So what happens here? Well, on the top we get 6 times the square root of 2. On the bottom we get the square root of 4. And what is the square root of 4? Well, that is 2. And here we got some good news. 6 can be divided by 2, right? So this is just 3 times the square root of 2. Now this last step is not always possible. Sometimes if this was like a 7, we couldn't divide it. We would actually just leave it. But, so what we find out is this. We find out that 6 divided by the square root of 2 is the same as 3 times the square root of 2. And so this is what we call simplified here. This is simplified form because we'd rather have things multiplied than a fraction, right? So this is simplified right here, okay? So that's how we made the denominator. Well, in this case, the denominator completely went away. All right, let's look at another example. All right, here's a little different one. We got the square root of 5 over the square root of 2. So again, we want to get rid of the square root of 2. We don't like that square root of 2 down there. So we're going to multiply by exactly the same thing, the square root of 2. Because when we're multiplying the square root of 2 times the square root of 2, this is just like squaring, right? All right, so we multiply. When we're multiplying fractions, we multiply straight across. 2 times 2 is 4. The square root of 2 times the square root of 5 is the square root of 10. So now we can clean up the bottom, right? Yeah, bottom is 2. Square root of 4 is 2. Square root of 5 we can't simplify. Sorry, the square root of 10. Okay, so we get the square root of 10 divided by the square root of 2. Okay, so we can't do anything with that. Don't try to go dividing this 10 by 2 because this is under a square root and the 2 is not. So we saw in the last one that the denominator completely disappeared. Here the denominator doesn't disappear, but it's a rational number. No square roots, okay? Square roots are irrational. We don't want those in the denominator. So one more kind of combination here, or something in between those two. We've got the square root of 6. We want the square root of 6 to go away. So we want to multiply top and bottom by that square root. That's what makes the denominator become a rational number. All right? So we got 2 square root of 6 on top. And then on the bottom, square root of 6 times the square root of 6. And that is the square root of 36. And the square root of 36 is just 6, right? Okay. So this is just 6 on the bottom. And we can clean it up a little bit here. We can only simplify things that are outside with things that are outside. So here, 2 goes into here once. 2 goes into here 3 times. So that leaves us with, let's see, the square root of 6 all over 3. And there's our final answer. Again, don't try to mess with these because one's on our square root, one's not. So we leave it alone. Square root of 6 divided by 3, or square root of 6 thirds, all right? And that's where we got to leave it, okay? So that's how we simplify an expression by rationalizing the denominator, okay? Multiply top and bottom by whatever that square root is. The bottom will become the square root of a perfect square, and that will clean up kind of like this. All right, good luck rationalizing the denominator.